found that the, just a second. And sorry for the inconvenience.
I'm sorry, I forgot to
yes.
My problem.
So
yeah.
It's okay. So let's continue. And so Dinino just analyzed the data, and he saw that he found that the total cholesterol values were higher in volunteers that were seen twice at an interval of 6 years. But the level of their triglycerides, the low density lipoprotein and high density lipoprotein were not very significantly different for the 2 visits. So Dinino was a bit confused, a bit suspicious, and he just talked to Coleman about the analysis of the data. He showed him the data, and then Dr. Coleman took the spreadsheet back for a cross-check, and he returned the spreadsheet after a week. Again, Dinino analyzed the spreadsheet, and this time, surprisingly, he found that the level of cholesterol, triglycerides, HDL, LDL, everything showed a significant decreasing trend over the 6 year. So actually, Dr. Coleman's theoretical assumption was when people starts aging, their blood glucose level rises or increases and their insulin level decreases. And also the metabolism, which is defined as a component of an individual's total energy expenditure here for each day, would show a decreasing trend or descending trend. So this was the hypothesis of Dr. Coleman. The blood glucose level will increase, insulin level will decrease, and the metabolism will decrease as people age. And this was the spreadsheet. I will just, so this was the spreadsheet that was, actually this was the original data, which was first provided to Dinino, and this is the modified or the manipulated data, which was received after a week, and it was manipulated by Coleman. And the red mark indicates that the data was reversed, and the yellow mark indicates it was falsified, and the sky blue mark shows or indicates as a fabricated value. So wherever Coleman found there was no data at all available, he entered some new value as per his choice, and wherever he found that the data is not so good as per his assumption or expectation, he just changed the data. He just entered some other value, and wherever he found that the data is showing an opposite order, like it was supposed to be a lower value in TEE in the second visit, but he found it was higher. So he just reversed the data in the first visit and in the second visit. So as we can see here, the total count of the volunteers in the first visit was only 55, and in the second visit it was 109. But while Coleman returned the spreadsheet, it was 135 volunteers in both the visits. And in the mean value of TEE, or the total energy expenditures in the volunteers, it showed a reverse value as per Coleman's assumption. So he just manipulated the whole data sheet to make it something which is absolutely meeting with his expectation or assumption, and he made this data publishable. And on the other hand, in a second data sheet, he changed the total values, almost all the values of glucose. It is the value of glucose levels in different individuals or volunteers that were seen in after 6 years, like an interval of 6 years. And here we can see that in most of the volunteers, they showed a decreased blood glucose level in the second visit after 6 years, whereas Polman's assumption was that the glucose level will increase with people aging, with people's age. And here the mean value of the glucose level was higher in the first visit than in the second visit, but Polman just reversed all the data and to make it something successful data or publishable data. And he just reversed everything, he just manipulated it so dramatically, systematically to make it publishable. So these were the two data sheets that were provided to Dinino, and he was absolutely surprised and totally suspicious. And so he was totally anxious about the discrepancies. He talked about it to Polman, and he asked Polman to re-verify the data by checking the original patient's record, whereas Polman responded in a different manner. And he stated that the records were unavailable. Sometimes he stated that he told that the records are lost. And on the other hand, sometimes he told the records are at his home when being asked repeatedly by Dinino. However, Dinino was even more suspicious and anxious, and so he tried to find out the original patient's record, and he found them suddenly in the graduate student's office. It was not in the house of Polman, but it was in the graduate student's office. He went through the data sheets, the patient's record thoroughly, and finally discovered that the spreadsheet had been systematically altered by Dr. Polman. With this evidence in his mind, in December 2000, he approached to University of Vermont Medical School's officials to file or register his first allegations. And after 1.5 years of investigation, in July 2002, UVM referred this case to the United States Attorney Office and the Office of Research Integrity, or ORI, for further investigation. And finally, in March 2005, the US District Court declared its final decision based on the investigative reports. So during the UVM investigation, the scientists in UVM who were in charge of the investigation, they actually went almost 10 years back to dig into all the data that were published, that were presented in grant applications and some scientific talks, and they found lots of discrepancies in all the data, and amongst which one of the most influential falsified data was published in the journal Annals of Internal Medicine in 1995. And here Dr. Polman tried to show how the energy balance and body composition are related and are altered during menopause. Actually, Dr. Polman claimed to have conducted a longitudinal study involving 35 women in the age between 45 to 48 who were seen twice 6 years apart. However, it was found that the longitudinal study was never ever conducted at all. None of the women were seen for a second time. And so in the second visit or in the follow-up examination, which was claimed to be performed after 6 years, were absolutely fabricated by Dr. Polman. Here, this is the table which was published in the Annals paper. These are the parameters which were seen in the first visit and in the second visit, but this second visit was never took place, and all the data in the second visit are absolutely fabricated by by Dr. Coleman. And in this case, one of the witnesses, I'd like to mention, one of the witnesses who was an author of this annals paper, he actually claimed that he tried to figure out the reliability on this data sheet, but Dr. Coleman threatened to fire him. And so he had to remain silent. But after repeated interrogations by the UVM investigators, that witness raised his voice. This was one of the most influential falsified data, and this annals paper were retracted in 2003, and there were 6 follow-up papers which were published in different years based on the preliminary data, specifically this table, and those were actually retracted. However, as a whole, the UVM and the ORI made their investigation, and they found they came up with 54 findings of scientific misconduct, and it was over a decade. And they found them as falsified data in different field of research, different areas of research, as I already mentioned about longitudinal study of aging, the 678 spreadsheet, and these data was presented to receive 2 NIH grant applications, to receive the NIH grants in 1999 and 2000. Also, the longitudinal menopause study, it was published in the annals paper, and then there were 6 follow-up papers published on the basis of the preliminary data. Also, Coleman received 10 different NIH grants based on this data. There are different fields of research where he falsified and fabricated data, like Alzheimer's disease, again in NIH grant applications, and the muscle biopsy, again in grant applications, the effects of hormone replacement therapy on postmenopausal women, again, 3 grant applications were made based on this preliminary falsified data. And also, he presented all this data in scientific talks, public talks. And the irony was, the most surprising part was, Coleman was absolutely aggressive when he was being interrogated by the investigators. He was just trying to run away from the truth. He tried to destroy all the electronic evidences. He tried to present false documents, submitted voluminous excuses, and preliminary, when the investigation actually started, then he claimed that the manipulated spreadsheets were just sent accidentally. And later on, he said there might be some simulations in the data, and for which he accused a biostatistician. Later on, he started blaming his junior colleagues. He told that he was absolutely unaware of the falsifications that were taking place behind his back. And the junior colleagues are absolutely responsible. They wanted to increase the number of publications, so they're falsifying the data. Then he went to the federal court also to block the UVM for notifying the ORI for further investigation. And when he realized that the case is going beyond his control, and there are sufficient evidence against him and to commence an ORI investigation, he suddenly resigned at UVM in the year 2001 and moved to the University of Montreal, Canada, with a prestigious position, and absolutely refused to return back to Burlington just to avoid the questionnaire by the investigation committee. He was very clever, very tactful, and very aggressive, defensive. However, truth never dies, as we know. So finally, after 5 years of prolonged investigation, interrogation, and defense by Dr. Pullman, he had to agree to a criminal and civil settlement, and he had to pay $180,000 US as a settlement amount for all the charges, criminal and civil charges that was against him. He had to pay 16,000 USD to Walter Dinino for the attorney's fees. And Pullman was absolutely permanently barred from getting any kind of federal funds or grants in future, and he had to retract and correct 10 scientific articles that were published between 1992 to 2002. And also he was permanently excluded from any kind of participation in all the federal healthcare programs. Last but not the least, the final humiliation was he was sentenced to a year in prison. So this glorified researcher, his career, his reputation, everything went in vain. Everything was ruined after this incident. And this was definitely a remarkable and alarming incidence of scientific misconduct that took place in the history of US research. And these were the publications that were retracted and corrected. So 10 publications were retracted and corrected. And that's all about Pullman case, Pullman story. Thank you.
Thank you very much. Before we open this for discussion, just a quick question. Do you know if he kept his Montreal position?
No. He had to resign from there also.
Okay. So you don't know what...
I really don't know what he is currently doing. Yeah. Where is he now? I tried to find it out, but anyways, I didn't get any information on this. So, yeah.
Thank you so much.
Okay.
I was not aware of this case, and this is, wow. Yeah. Some thoughts, responses from others? Open your mics and shoot.
Mm-hmm.
This is, of course, a very important topic because each time we go to physical and we get our blood drawn, LDL, HDL, and so on are being measured and so on. And he had some idea and tried to force his hypothesis into data.
Mm-hmm. And also all his publications were highly cited because he was a very renowned researcher in the obesity field. And
so, yeah, actually it would be very interesting to look at Google Scholar and see what happened since.
Yeah.
Maybe somebody can do this quickly, put his name in Google Scholar, and then you can show the screen and see what happened to the citations. Any other thoughts? So cheating is not, doesn't pay. We know that. But you could possibly cheat some of the people some of the time. Eventually, if you are caught, you're going to pay very dearly.
Yeah.
So there is a chat comment from David. If I understand correctly, he cannot participate in health programs. Isn't it a bit harsh? Well, the guy cheated. The guy gathered many millions of dollars of funding from NIH based on his cheating. This is pretty severe. You don't want that person to treat patients.
Yeah, I agree.
Any other comments? All right. Thank you very much, Sampita. And the next is Garima. Did I pronounce your name correctly?
Yes.
Okay, go ahead.
So is my screen visible to everybody?
Yeah.
So, all right. So today we will discuss about scientific misconduct in cancer research, and we'll try to understand the consequences of it with the help of case study of Bharat Agrawal. He was working on cancer research, and this will be the overview of our discussion: how he got exposed, and what were the retraction notices, and what was the reaction of the spokesperson after news was out. And we will also look at some evidences and the total retracted paper, and what is he doing currently. So we know that scientific misconduct is unethical practice in research field. So if we talk about the numbers, according to 2019 systematic review and meta-analysis of the survey data, approximately 2% of the scientists has admitted that they had falsified and fabricated results. And I'm pretty sure this number is an underestimation, because there are many who never admit that they actually did such kind of work. So let's take a minute to understand how it actually impacts if the fraud is happening in medical field. We know the nature of life science. The research in life science is pretty slow. So let's say if a person X is doing some study during his career or during his PhD, it leads to a small finding which makes the basis of another person's research. So we all familiar with the nature of the research of life science. It's pretty slow. That's not the only thing. The research in medical sciences is directly linked to the patient's health. Whatever is the finding, it gives patients hope that they can be cured. So it is connecting to the health. Let's try to understand what could be the consequences of scientific misconduct in cancer research. We'll try to understand this with the help of case study of Bharat Agrawal. He was a renowned professor in cancer research at MD Anderson Cancer Center, the University of Texas. Of course, he was working on area of cancer, and obviously he did fraud, and that's why he had to resign in 2015, because whistleblowers found out falsification in his images, in his results, in approximately 65 papers. Okay, so what actually motivates a researcher to do fabrication of the data? Maybe they want to go to good institute, or they want to get many grants. Okay, if that's the case, let's take a look at the Bharat Agrawal's career. He has always been to one of the renowned institute or university in the world. Not only when he was doing his graduation, but also when he was employed as a scientist. He was chief of cytokinin research section. So he has always been employed at really good positions. At the same time, he was publishing many papers, and he was publishing many books. One of the book who got really famous, it was Healing Spices, and where he mentioned that how spices can actually cure disease or boost immune response. So no doubt he has an outstanding career. He was working on so many things, and also he was getting really good results about it. So basically he was working on cytokinins and the role of inflammation in cancer, but major of his study was focused on anti-cancer effect of spices and herbs, particularly curcumin. What is curcumin? It's a chemical constituent in turmeric, which leads to yellow color of turmeric, as we see here. So let's take a look at his experiments and what was his finding. He demonstrated the benefits of curcumin and turmeric. Along with that, he showed results that curcumin has anti-cancerous potential. So it can be used to cure cancer. Okay, so far. So what he did exactly, okay, if we want to understand how these drugs are accepted, if they are actually anti-cancerous, So we take a cell line, we put it into the mice. This is called xenograft, cancer xenograft. So after putting it into the mice, the cancer developed inside it. And then we, at certain stages, we give doses of the different drug and we see that if the tumor is suppressing or not. So that's the basic protocol. He did the same. He did the colorectal cancer xenograft in mice and gave different doses of curcumin, turmeric, and CTF. This is basically that he took the turmeric, extracted the curcumin out of it, and then used the rest part as a dose, as a drug. All right. So after giving the different doses, he found out that tumor suppresses after the treatment. And he also figured out the doses for all these three components. So since he already laid the foundation for clinical trial that curcumin can cure the cancer, he also found pharmaceutical company. And what happened is, along with that, like he owned the company to develop the synthetic analog of curcumin. And along with that, he had 33 patents throughout his life. And there was a company called SignPath Pharma. They licensed 3 of his patents for because they were seeking to develop liposomal formulation of curcumin. So he was getting money from selling his patents, and also he was getting grants because he had so many outstanding results throughout of it. All right. So, but at the same time, in 2012, academic whistleblowers started finding the evidences that he is doing fraud in his many published papers. So accusations were basically on falsifying the images, as in adding, subtracting features out of the images, cropping, rotating, and stretching the figures, and somehow making it different all the time, and flipping horizontally and vertically the figure. These were the allegations which were claimed to happen in many of his papers. Along with that, okay, so first proof of his image falsification were published in Abnormal Science, and this was a German blog. And at the same time, there were few whistleblowers which were talking to the Chronicle newspaper. And there was one of them who was Japanese. He gave a lot of evidences to the Chronicle newspaper from his articles 2004 onwards. But he said that I'm pretty sure that he can find more falsified results if he will look into 2000 to 2004 articles which were published in these years. And there was a USA there was an American whistleblower. He was also providing evidence to the Chronicle newspaper. And he said that he will continue to look for all the evidences he can find. So of course, the study we just talked about, it got retracted because there were too many falsification in the results. And then, just a second, I'm trying to move. I'm sorry. Okay. So then another paper got retracted called Celestrol triterpene enhances trial-induced apoptosis through the downregulation of cell survival protein and upregulation of death receptor. Why this paper got retracted? So the first retraction notice said that this article has been retracted by the publisher. An investigation at MD Anderson determined that images has been reused to represent different experimental conditions. Specifically, the actin immunoblot in figure 1D left and JNK immunoblot in figure 5B were reused. And then again, in figure 5D, the images showing MDA MB231 cells transfected with scRNA and treated with medium, as well as the images showing MDA MB231 transfected with scRNA and treated with trail were reused. I apologize that I cannot show you these pictures because the paper was retracted and there was watermark on the paper, so we cannot compare different treatment. But let's look at the figure 1D and 5B what retraction notice talk about. So this is the figure for Immunoblot, which is used for checking if the cells are expressing certain specific protein. Look at these two bands. These two are different proteins. And what is the difference between these two bands? Just the lower one is a little fainter. That's the only difference. Let's take a look at these two, beta-actin and JNK. Nothing, the image is a little bit more stretched. That's the only difference. Then again, another paper got retracted, which was entitled as Crotepoxide chemosensitizes tumor cells through inhibition of expression of proliferation, invasion, and angiogenic proteins linked to pro-inflammatory pathways. Okay, why this was retracted? The notice says that this article has been retracted by the publisher. Analysis by the journal with image analysis software determined that the figure 4C has been inappropriately manipulated. Look at this figure. This figure was actually faked, completely faked, and software detected it. All right, so and these things were happening, federal government notified the MD Anderson Cancer Institute, and then MD Anderson's spokesperson released his statement saying that MD Anderson is committed to the highest standard of a specific integrity. Any scientific work that does not adhere to the highest standard of scientific integrity is not acceptable. MD Anderson also supports organizations and journals like Journal of Biological Chemistry when questions of scientific integrity have been raised and they have determined that steps must be taken to correct the scientific records and ensure the scientific integrity. Right. So all over, after the notification was released, he has to resign, and all over 29 papers of him was retracted. 10 others were expression of concern, and 17 others were corrected. And so after these all things were happening in 2015 to 2016 range, and few of his article again got retracted also in 2018. But after this, after looking at these data, I thought that I was wondering, what is he doing nowadays? And I looked at his Google Scholar profile, and it was quite astonishing because look at the citation he got last year. In 2021, he got almost 11,000 citation on his articles. And when I started looking at the paper he's publishing, he's still publishing. And in last year, he published 8 articles, and most of them are in reputed journal, which does not make any sense if a person is not affiliated to any institute.
So what is affiliation right now?
So the affiliation, now he's working as Inflammation Research Center.
In India?
No, in San Diego.
San Diego. So that's not a university, that's some kind of institute?
Exact. I really couldn't understand because the website says that he's a founding director of Inflammation Research Center. And when I looked at this website, I couldn't find any other name except Bharat Agrawal. There was nobody over there.
Okay, so that's a fake institute. I guess his home address.
Maybe it's a fake. And also they had
I think you are frozen. Okay, we cannot hear Karima. Let's wait another second. Okay, I think that we lost her. I can actually finish this because I have the presentation. So let's try to.
I'm back.
You are back. Okay, so can you share your screen?
Yes. So all the websites we see, it's a bit fake. We really don't. I couldn't understand what is he actually doing.
But he is on papers.
Yeah, he's on papers, and there are a few more scientists with him, which is like he's obviously the the project is his, but there are co-authors, second authors, and third author, and there are other people in his papers. So
wow.
We really can't say anything what's actually happening. So far we understood that unethical conduct is present all over the world, and people are doing it, and it has hazardous consequences. We visualized it. Okay, think about it. He already released his finding about curcumin, and he said that everything is right. So if whistleblower would have not caught him falsifying the results, he had his own company. He could have faked the clinical trial data too. He already laid the foundation for clinical trial, and he was going to start the clinical trial for curcumin. And whenever it happens in any medical field, it gives hopes to the patients that they are, they can be cured. But what if everything is false? So we visualize the consequences of fraud in medical field with the Bharat Agrawal's case. But it makes me wondering that if these people should be still allowed to work and to publish data after their integrity has been already questioned. Maybe he has learned from his mistakes, but can we trust him? I will leave you with these questions. Thank you.
Great, thank you. So 2 comments. One, I think I shared with you a few weeks ago that many journals now have AI software to look at images. As it turns out, many people were faking or not representing, at least not representing correctly, gel results, blots, and so on. It's very easy to manipulate these. We just recently submitted a paper to one of the Nature babies called the Communication Biology, and the amount of work they demanded for every single data and going through all the filters, that was, a whole project for several weeks just to submit everything. Because of such cases, they are now much more careful in terms of accepting gel results or blots results and manipulation of images. This AI software is now looking into manipulations of images. As you said, it's much more common than what we think. And hopefully using these AI tools will help in preventing such cases in the future. That's one comment that I have. The other comment is I'm appalled to see that he's still publishing. I think this is a fake affiliation. He had to resign from MD Anderson and went to San Diego and just put some kind of affiliation. But as you said, it's not an LLC, it's not an incorporated entity, it's not academia, it's not company, it's whatever it is. And under this name, he still publishes, which I find this to be amazing. Comments?
Along with that, he's publishing to really reputed journal. I'm really
So
not.
somehow it's not going through the filters of the peer review at all. Again, supporting my claim that peer review doesn't work. Others can contribute to the discussion, comments, questions?
I have a question.
I'm trying to go ahead.
Okay, thanks. His titles were not revoked. I mean, his PhD, his MD, if he were. I mean, he's still.
I think he get away with everything. So.
Yeah, it sounds like better than what happened to Sean or to the previous case, right? So as long as he keeps his title, in principle, he can publish. I would expect peer review to do a better job and figure out that he falsified data in the past and be very suspicious about his current papers. Yeah, there was Ron. Can you go ahead?
Yes. I was just wondering, I mean, people know about what he did, right? So, I mean, I'm assuming the editors of the journals know about it. So if they decide to send for a review, I mean, I'm just trying to understand what's going in their minds. I mean, are they aware of this or not?
Yeah.
I mean,
good question. Gabriel, this is one of the best, presentation we had just in case of what's happening. We don't know what's happening on this. There is no conclusion. And it's up in the air. I mean, I find it amazing that he can still publish. He somehow managed to get unscathed from this whole episode, and it's we hope for better resolution of cases like this, because you have to, once you find fraud, you have to condemn it and make it an example for others. And
but it is possible that not all of his publications are
yeah. Look, we can give him benefit of the doubt and say that he totally transformed and he's now a good scientist. He's very careful and maybe we don't know. I find it weird that he has this affiliation that is so vague. Obviously, he lost his job. No other university will hire him, and so he had to do something. It's not clear, but you also need some funding, right? You need to bring bread home at the end of the day. So maybe he has some kind of funding. I don't know. He has a sugar daddy that gives him money to do research. I don't know. It's interesting case. It's not resolved. That's not the last word. Any other comments? No, thanks again, Rima. It's great. And the next speaker is Chaya. You can share your screen and go ahead.
Thank you. Can you hear me and see my screen? Okay. So hello everyone, and thank you so much for joining us today. My name is Chaya Amichai from Physics Department, and today we are going to speak about the faster than light neutrino anomaly. So let us start with a little quiz. So go to Mentimeter with this code. I'm going to open Mentimeter. Oh, the code is 39019602. It's now on chat. And so what is neutrino? It's elementary particle, indeed. You don't know, that's okay. Smallest particle, maybe. Weakly interacting, that's right, thank you. Electron with no charge, not precise. Another don't know, neutral, that's correct. Okay, so now we're gonna see what is a neutrino, what our whole story is about today. So let me go back to the presentation. Okay, so preface, what are we gonna do today? So today we are going to speak about a little bit of the history and the background of the neutrino, of the of the mistaken discovery that the neutrino is faster than light. We're going to speak about the detection of what the system looked like and how did they mistakenly detected it. We're going to speak about the first results, the internal replications and the errors, and another independent replications. We're going to speak about the reception, how the physics community accepted this whole story. And we're gonna sum things up. So let's start. Okay, so history and background. Let's start with the basics. What is neutrino? So as you see here in the picture, we have 4 kinds of neutrino. We have the electron neutrino, muon neutrino, tau neutrino, and sterile neutrino. But neutrino is, as some of you said, it's an elementary particle with a spin quantum number of half. And its name is taken from Italian little neutral one, neutrino. It have a neutral charge and, and almost, not zero, but almost zero mass. It interacts only with weak interaction and gravity. So the rest mass of neutrino is really, really small, and it is much smaller than other elementary particles, excluding the massless particles. So why the neutrino interests us? Why do we research about neutrino? So neutrino low mass and neutral charge, as we said, mean they interact exceedingly weakly with other particles and fields. So this feature of weak interaction interests us because it means neutrinos can be used to probe environments that other radiation cannot penetrate. So that was a little bit of the background. So let's speak about the history, where it all started. So it all started with Wolfgang Pauli on 1930. Wolfgang Pauli postulated the neutrino, and he wanted to explain how the beta decay could conserve energy, momentum, and angular momentum, unlike Niels Bohr that explained it more statistically. So that's what Pauli postulated. He said that when the beta decay happens, the neutron, he called it at first neutron, emits from the nuclear together with the electron or beta particle in the process of the beta decay, and it had a mass similar to the electron. That was first. Then came James Chadwick on 1932, and he discovered a much more massive neutral nuclear particle, and he also named it a neutron, leaving 2 kinds of particles with the same name. But the real reveal was when Fred Rines and Clyde Cowan on 1956 experimentally discovered the neutrino. So what they did was their experiment called the Cowan-Rines neutrino experiment. A year later, it won a Nobel Prize, And they created a nuclear reactor by beta decay with protons to produce neutrons and positrons. Then the positron quickly finds an electron and they together annihilate each other. The two resulting gamma rays are detectable, so the neutron can be detected by its capture on an appropriate nucleus, releasing a gamma ray. The coincidence of both events, positron annihilation and neutron capture, gives a unique signature of an anti-neutrino interaction. So they found this anti-neutrino interaction, and that's why the anti-neutrino exists. But this is the whole history of our story. Our story starts far after that, on 2011, on CERN and LNGS labs. On September 2011, the OPERA experiment mistakenly observed neutrinos that traveled faster than light. This is considered anomalous because to find this kind of finding, it violates the special relativity because no particle can move faster than light. It would violate the special relativity. So this is where our whole story begins. Okay, so the detection. The experiment was like that. They created the neutrinos at the CERN SPS accelerator. As you see here on the left picture, this is the CERN older particle accelerator. So they made the neutrinos there, and then they detected them at LNGS detector in Gran Sasso, which is in Italy. So they used a common view GPS that derived from standard GPS. They measured the times and the place coordinates. Then they could calculate the time of flight. They could calculate the time of flight, and they found that this time of flight is much shorter than if light would go through this path in vacuum. Means that the neutrino particles are faster, their velocity is faster than the speed of light. So they did again the experiment. They tried to create those neutrinos in other ways, such that they could measure each unit neutrino separately. And again, the neutrinos had velocities faster than the speed of light. Okay, so the first results. In 2011, March, they analyzed their data, and the OPERA team reported evidence that the neutrinos they produced at CERN in Geneva and recorded at Gran Sasso, Italy, they traveled faster than light. So they released this evidence. So to be exact in numbers, the neutrinos particles arrived the detector 60.7 nanoseconds sooner than if light would go there. After 6 months, they did a lot of checkings, a lot of another experiments, again and again, another way of creating those neutrinos, and they found the same results. So they announced that the neutrinos had been observed traveling faster than light. So they asked themselves, is it make sense? Maybe does it have to do with the energy of those neutrinos? So they redid this experiment, with higher energies and lower energies. And again, they found that the velocity of the neutrinos is still higher than the speed of light. Okay, so what we see here is one of their tables. They did this experiment with a big amount of neutrino particles, and what we see here is the blue line is says that most of the particles were around 60.2 or 62 points point a little. Now they arrived 62 seconds sooner than light. Okay, so after a bit, eventually, they found their measurement errors. So one of their errors was that a link from a GPS receiver to the Opera master clock was loose. It increased the delay through the fiber. This glitch's effect was to decrease the reported flight time of the neutrinos by 73 nanoseconds, and it's making it seem faster than light. Another error was the clock. A clock on the electronic board ticked faster than it expected, around 10 megahertz frequency. And this is lengthening the reported flight time of neutrinos, thereby somewhat reducing the seeming faster than light effect. The Opera team stated that the component had been operating outside its specifications. So they corrected these two errors, and they unfortunately find that the speed of the neutrinos was the same as the speed of light. Okay, so another applications. They tried to do another experiments. So what they did was changing the detectors. As you see here, we have the Icarus system, the LVD system, and the Boraxino system, which all located in LNGS lab on Italy. They use the same SPS accelerator with different detectors. And again, they found that the speed of the neutrinos was the same as the speed of light. And that's how they refuted the Opera experiment, and the speed of neutrinos is not higher than the speed of light. Okay, so reception. How did the physics community accepted this whole story? Okay, so physicists in the field were quietly skeptical of the results, but are prepared to adopt a wait-and-see approach. So several well-known experts did make public comments, and here's one of the comments that in a way sums up the general comment of all. So despite the large significance of the measurement reported here and the stability of the analysis, the potentially great impact of the result motivates the continuation of our studies in order to investigate possible still unknown systematic effects that could explain the observed anomaly. We deliberately do not attempt any theoretical or phenomenological interpretation of the results. So this is how it sums up. Physicists around the world did not did shaming to that experiment. Okay, so questions that I raised to myself through this work was a few of these questions. So how did the Opera team was so sure about their findings? Because, you know, as a physicist, we know that nothing can move faster than the speed of light. And they were so sure, and and they published it. So how were they so sure? Another question is, why did they run independent replications? And although the internal ones did refute their opera experiment. So why did they need another replications? And how significant is the real findings? Those were my questions. And that's it. Thank you so much.
Right, are we done? Yeah, great, thank you. So few comments of my own. I actually remember this case, and it made the news, and it was really a huge discovery. But immediately in Science, Nature, commentaries, editorial pieces, all doubted it very much, and there is immediately a scrutiny by many, many teams proposing all kinds of reasons for artifacts. What I find amazing, starting from physics, ending up in biophysics, is control experiments. We talked a little bit about this. Physicists are not used to control experiments. This earth-shaking result could have been prevented if they had done, as you suggested, some control experiments, doing the same measurement by 2 different detectors and 2 different methods and so on. But at the end of the day, it was a stupid artifact of just delays in, I mean, the clock was wrong and the synchronization was wrong. And that, by the way, was suggested by other teams immediately. And they were sure that they've done everything right, but they didn't do a good control experiment. Any thoughts, ideas? So this is a great example.
It was very good, that's all.
Yeah, this is a great example. I mean, we talked about fraudulent science, we talked about errors, we talked about mistakes. I think we are covering a whole spectrum of scientific conduct. So these guys are not crooks, but they have not been careful enough. And as a scientist, you need to be careful, you need to be very modest, and you need to think twice before you come out with earth-shaking results. You need to be so absolutely sure about this. And at the end of the day, they came out and they had to retract and basically come up with a much simpler, mundane explanation for what they observed. Anything else? All right, no, thanks again. And to the last talk of today, this is Ron. You can share your screen.
1 second. Okay, I think. Okay. Okay. 1 second.
So you are going to show us how Einstein was wrong?
Well, it depends on your interpretation, I guess.
Okay.
But I'm gonna talk today about one of my favorite papers ever. It's called, usually people refer it as the EPR paper, after Einstein, Podolsky, and Rosen. And the title alone is, this is the title of the paper: "Can quantum mechanical description of physical reality be considered complete?" So I'm going to jump ahead and start telling the story. First, some background. So up until this point, by 1935, conceptual understanding of quantum theory was dominated by Niels Bohr's idea concerning complementarity, which means that according to complementarity, when we observe the position of an object, we affect its momentum uncontrollably. Thus, we cannot determine both position and momentum precisely, which means that if I take a measurement, then by the act of measurement, I interfere with the system, and therefore, if I measure the position, let's say, then I'm affected in such a way that the momentum would be indeterminate. So this is the view by Niels Bohr, and Einstein thought that there is such a physical reality that the particle does have both position and momentum, and it is probably possible to, in some way, without disturbing the system, to acquire both of these physical quantities. So first, Einstein was quite enthusiastic about quantum theory, but he had some reservation. He was a bit disappointed by some of the aspects, which mainly the reality. I mean, according to quantum physics, then if you think about superposition, then or I don't know, if you think about, let's return to the example of momentum and position, then according to Einstein, there must be some theory that give you the whole picture and not just some of the picture. And also the theory was fundamentally probabilistic, but not due to ignorance, but because this is what the theory says. And it really didn't sit well with Einstein. So on May 3rd, 1935, published by the New York Times, you can see the headlines, was this paper. It's actually a funny story. Podolsky actually leaked it to the New York Times without the knowledge of Einstein. Einstein didn't really like it, but that's not the story here. I'm going to read just this part because it's quite interesting. Professor Albert Einstein will attack science's important theory of quantum mechanics, a theory of which he was sort of a grandfather. He concludes that while it is correct, it is not complete. With two colleagues at the Institute for Advanced Study here, the noted scientist is about to report to the American Physical Society what is wrong with the theory of quantum mechanics. The quantum theory with which science predicts with some success interatomic happenings does not meet the requirements for satisfactory physical theory. Professor Einstein will report in a joint paper with Dr. Boris Podolsky and Nathan Rosen. All right. So this is the paper. It was published less than 2 weeks later. So it was leaked, and then so they submitted it, and it leaked it, and it got published in the New York Times. The story of it just before the actual paper was published. There are a few things I want, before I'm getting into the physics here, there are a few things I wanted just to comment, which I find interesting. First of all, I mean, how many times do you open a paper and the title is a question? This is quite unique, okay? The title is a question. Usually you see that when you go to a talk, it's more common there. Another thing, which is I find to be really interesting, the paper has no references. They didn't cite anyone. So it's quite amazing. I mean, if they're talking about quantum theory, then they should at least, I don't know, mention some of the godfathers of quantum theory. They should mention Schrödinger equation if they use Schrödinger equation or something like that. I'm just saying. Just another remark, this paper has close to 10,000 citations, and it is quite, I don't know, impactful paper, I would say, even though they basically pose a question and try to rationalize whether quantum theory is complete or not. Now, I'm going to go through this paper and like following the logic of this paper and see how I can deduce the results, pretty much. So I'm going to just follow their lead. All right, so first you can go to the definitions they define. Every element of physical reality must have a counterpart in physical theory. If without any way disturbing a system, we can predict with certainty the value of a physical quantity, then there exists an element of physical reality corresponding to this physical quantity. So for them, a theory, if it's complete, then I should be able to predict with 100% certainty the outcome. Otherwise, something here is missing, or for example, you can think example for such a case, for such a good case, is when the system is in some eigenstate of an operator, then you would know that with certainty that the eigenvalue will always be measured, like 100%. This is like an example. Now I go through, there are two arguments in the paper. I'm going to go through both of them. They're both important because they use the first one they explain the first one, and then they explain another one, and then they use the result of the first argument in order to contradict quantum theory in some sense. All right, so the first argument is as follows. E pairs assume an eigenstate of momentum. and show that in such a case, the position is indeterminate. So how they do that, they try and they assume an eigenvalence of momentum, and they try to evaluate the probability of finding the particle within a specific, within some difference of places. So they saw that it does not depend on where is the difference, which means the probability to find the particle anywhere is the same. So basically the position is completely indeterminate. So according to their criteria that I presented before, it means one of two things, okay? Either the quantum mechanical description of reality given by the wave function is not complete. Okay, this is one possibility. Another possibility, when two operators corresponding to two physical quantities do not commute, the two quantities cannot have simultaneous reality. So one of the two must be the case according to how they address this issue. So I just make this comment. In order for one to hold, number two must be false. So this is something we will use ahead. Okay, so EPR second argument, they hypothesize two particles or two systems, system one, system two, and the two systems interact between time equals 0 and time equal capital T. Assuming they know the initial state of both of these systems, they can calculate theoretically the state after the interaction, all right? And at a later time, T greater than capital T. So whatever they do next, after doing that, after they have a wave function psi, and this wave function psi is supposed to describe the entire system, but it actually gives a description of both of the particles together. It does not give you a description of particle A and particle B, but according to Einstein, these are two isolated particles now. I mean, after the interaction, they no longer interact. You should be able to have a description for each part of the system individually. And they mentioned that in order to do that, you need to create a measurement, which they call also reduction of the wave packet. Okay, this is the formalism that was known. This is actually still today. This is how you think about it. Okay, so then they go on and say, okay, assuming I measure according to an operator A, system one, and I find it to be in some state, UK, let's say, and so automatically it leaves the system in some state psi k, the system B, system two. Let's say they do it again. This time they measure for a different operator. They measure system one in different operator. Then it leaves the system with another state, phi r. But you need to remember, all they did is think about measuring only the system one, which means that whatever they do, they are not affecting system two, according to this view. Because of that, it means that both of these states for system two, psi k and phi r, both of them are actually correspond to some real properties of system B, right? Because they didn't interfere with that system. Then they go on and actually specify a specific type of wave function, just for an example. And they demonstrate that, okay, if they use first the operator, the momentum operator, and they measure it, and let's say they got P, the momentum for particle one, they got P. So according to the state they had, it means automatically that the momentum for particle B is minus P. They can think about the same scenario, this time with the position operator. And if for particle one, they get X, then the position for particle B must be X plus X0. Okay, so again, if I follow the logic from the previous slide, it means that because these are both pictures of reality, it means that it is true that that a system does have both position and momentum simultaneously. It is actually a real thing, according to what they see here. But now that I use the argument, the first argument, I combine the two, then according to premise one, either the quantum mechanical reality given by the wave function is not complete, or when the operators corresponding to two physical quantities do not commute, the two quantities cannot have simultaneous reality. By negating premise one, they infer that quantum mechanical reality given by the wave function is not complete. So this is basic logic, what they did here. Of course, it's only true under the assumption they made, all right? So we'll get to that. I mean, this is just the beginning of the story. I'm just gonna summarize. In case people missed out on the logic, it's okay. Separated systems as described by EPR have definite position and momentum values simultaneously. Since this cannot be inferred from any state vector, the quantum mechanical description of system by means of state vector is incomplete, okay? I'm gonna mention a few key features of this EPR paper. EPR is about interpretation of state vectors and employs the standard state vector reduction formalism. The criterion for reality affirms that the eigenvalue corresponding to eigenstate of a system is a value determined by a real physical state of the system. Separability. A separated system have real physical states. Locality. If system is spatially separated, the measurement on one system does not directly affect the reality of the other system. It may affect later, but not at the same time, because it takes some time for whatever I do here to have effect there because of relativity, special relativity. If quantities on separate system have strictly correlated values, those quantities are definite. This is the same thing, right? I mean, if I have, because they're separated again, then if they are correlated, they were before the measurement. They're already been correlated, so it's definite. Completeness. If the description of system by state vectors were complete, then definite values of quantities could be inferred from the state vector for the system itself, or from a state vector for a composite of which the system is part. So basically, they want to have such a, let's say, a wave function or other function that you can deduce everything from. Okay. All right. So actually, Einstein wasn't really happy about the way this paper was written. I don't know if I mentioned it, but actually, I didn't mention it. I will mention it now. What happened is Podolsky actually wrote the paper and he submitted it before Einstein got to review it. So Einstein never saw the manuscript. So he just saw the paper and he wasn't really pleased with it. One of the main objections for him was non-locality. He thought that this is the big issue. He didn't really care about the whole simultaneous momentum and position. What he really cared about is how can one measurement in one part can have instantaneous effect on a very, very distant system. This is what really bothered him. And also the fact that, oh yeah, I think I mentioned everything here. Okay, so because locality, the real state of particle B could not depend on which kind of measurement was done in A. Therefore, the quantum state cannot be in one-to-one corresponding material states. Okay, so another few things I wanted to comment regarding Einstein's view is, first of all, people assume that he was a big enthusiastic regarding local hidden variables, which I will explain briefly. But actually, he just thought that it could possibly give a description. What I mean by local hidden variables is that maybe there is one reality, there is a reality. So maybe you can think of the physical system, the quantum system, as a real system in the sense that you have a definite value for every observable you want, but you just don't know what it is. And maybe there are some variables that are local, which means that they cannot affect distant parts of the system immediately. That could give such a description. So he thought it is possible, but he actually preferred that. He actually thought that maybe it is better, instead of trying to fix quantum mechanics by using whatever is available there, maybe to come up with a completely new theory. Maybe think about some other assumption and go from there and start building it from scratch. Okay, so he was kind of a rival of Bohr, and 2 months later, Bohr published this paper. which is a response. I'm not going to go into much detail. I'm just going to say that basically he said that whatever Einstein deduced is wrong, because according to complementarity, when you measure one operator like position, then it precludes your ability to measure the other one. So you immediately affect the other one. So the whole inference of they did according to Bohr was incorrect, and actually the theory is complete. All right. After that, there was a David Bohm version. So in 1951, David Bohm published, he published a book on quantum theory, and he knew about EPR and he wanted to include this within his book. So he tried to think about a way to implement it in a simpler way. He thought about spin states. So in his idea was, let's say you have a source, you produce electron and positron, and the total spin of the system is 0. Okay, so the electron goes to system A and Alice, and the positron goes to Bob. And because the total spin is 0, it means that, let's say if Alice measures in the Z direction, let's say she got half, then it means that if Bob would measure in the same direction, he would get -half. So they're completely anti-correlated, independent on which direction they measure the spin. So this is this version, and later, a few years, like 6 years later, he published a paper with Yakira Aronov from Technion Haifa, and actually he's probably everywhere. He's also in Tel Aviv now. He's everywhere, Yakira Aronov, and which basically showing experimental setting of how can you actually test the EPR. I mean, EPR showed that there is a possibility of really interesting correlations due to quantum theory. So they basically took the idea that I just described with the spins and showed how it can actually be done in this paper to test the entangled spin correlation. By the way, it's interesting to note that entanglement, this is something they use later. I mean, back in the EPR, when the EPR came up, people never said entanglement, but now we know it is actually what really bothered them is entanglement, the instantaneous effect of entanglement. Okay. After that came Bell, which is also a big progress. Basically what he did, I mean, I explained briefly about local hidden variables. So I'm not going to go into details because Bell by itself is a whole talk. So he started by assuming a hidden variable theory, probabilistic theory, deterministic theory, that you have some hidden variables. And then he came up with this inequality, and he showed that this inequality, I mean, is violated if you assume non-local hidden variables. And also it is violated by quantum mechanics. So actually what it means is if you want to construct a hidden variable theory, a local hidden variable theory, you cannot do it. So it is actually, what I'm saying is just the tip of the iceberg. This paper is so significant, and so much foundational work in quantum mechanics has been done thanks to this paper and thanks to the EPR. And I'm pretty close to the end, so I'm gonna conclude with some discussion points. Okay, one of the things that I thought about when I read the paper, I mean, obviously I liked it, but can a paper that does not describe new experimental observations or new theoretical tools or predictions be considered scientific? Because in some sense, this paper is about a question. They pose a really important question about reality. Yet it had great significance. How important is it to understand the underlying of working theory versus knowing how to use it? Is it worth pursuing foundational question, or do they belong to philosophy? So I just love that this paper being just a question, even though maybe Einstein was wrong, but let's say it's not even the point here. The point is by asking this question, it really helps you think deeply about the nature of things and try and come up with different ways to understand what's going on and come up with new theoretical perspective and really help to progress science. So this is it. Thank you.
Great, thank you. So I'm not sure it's Einstein that was wrong. Maybe it's Podolsky because he didn't give Einstein to the last read before submission. But as you said, entanglement has proven over and over again over very, very large distances. So that's what bothered him, and apparently he was proven wrong.
Yes, I mean the concept of locality is broken by quantum mechanics, and this is what really bothered him. But maybe it would, I don't know, make him feel better that the fact that you cannot use this as a way to transmit information faster than light. So even though there is some non-local effects in quantum mechanics, you cannot use them to your advantage as far as transmitting information. You can use them in other respects.
Well, you can use them in computation. You can use
exactly.
them
Yes, in many other things.
Right.
In sensing, quantum sensing,
right.
quantum technologies, etc. So I just hope you enjoy this this whole thing.
Yeah, and that definitely fits the general theme of the course, because we talk about how to do good science, and sometimes just asking the right question is a trigger for a lot of good science to follow.
Okay.
Any other comments, questions? All right, so it's getting late. We will finish here. Thank you so much for all the speakers today. And our last class will be next week on Tuesday. It will be in hybrid format. I guess the same room, if I'm not mistaken, that was 303. And hope to see you in person next week. Good night, everybody.
Good night. Bye.
Thank you.